Okay, today's discussion will be on sequences. What are they? Well, sequences are simply the output values of some mathematical pattern. So, in the most basic arithmetic sequences, let's think back to linear equations. Here we have three girls for every boy. Three girls for every boy. So when we fill in a table, we're going to have three. We're going to have three. Wait, what work? We're going to have six. And if there's nine girls, there must have been three boys and three girls for every boy, right? So one times three, two times three, three times three, and four times three. So here we have the outputs. You put in the number of boys, you're getting out the number of girls. If we just think about those numbers as a list, what is a sequence? Since it has a common difference, it's an arithmetic sequence. In other words, if I take any one of these numbers and I subtract the one before it, I find the common difference, the change, the slope. Back in linear equations. And instead of writing the whole table, we say the first one is 3. The second one is 6. The third one is 9. The fourth one is 12. And the nth one is the one before that. Like here, the fourth one is the third one plus 3. The nth one is the one before that plus 3. This is called the recursive way to write this, recursive. Why do we do that? Well, it's a way to think about it. It's a way to think about it. So we know what the first one is, and then we know how it changes from one to the next. That's mathematically what we're supposed to be thinking about. So we have this recursive sequence and it's arithmetic, linear. And then if we were to move to the next one, let's take a look. So here's another sequence. It's a sequence of figures. It's following a pattern. And we know what that pattern is uh, because we can see, somehow I've got my highlighter on. Let's see, pen. Okay. We can see the first one, the first one has three blocks. The second one has five blocks. The third one, and I'm doing this on purpose because I want you to understand what these things mean. The third one has seven blocks. And the sequence would be 3, 5, 7. If I asked you to write the next couple, I bet everyone could probably figure it out that it would be 9, 9, 11, 13. We could probably go on and on and on figuring it out. Okay, well, That's because we found the common difference. The common difference is 2. In other words, the change is 2. So we could write this out as a recursive. We'd write the first one is 3, and the nth one, that means any number, is the one before it plus 2. We might see on our Alex, we might see it written this way: 2 plus a sub n minus 1. It's the same thing. In addition, it's commutative, so you can switch those. So this is just the recursive way. How would you write this as an explicit formula? Well, you'd write y equals 2, and we'll use the x minus 1. X minus 1, that shouldn't be there. Oh my gosh. So how would you write this in the explicit way? The explicit way, well, we would write f of n. We're using n instead of x today. It doesn't really matter. We could use x. Doesn't matter. Okay. F of n equals 2 times n minus 1 plus 3. This is because we use the first stage that has 3 in it. Okay. If we went to find a stage 0, okay, we'd have to take 2 off of that. We'd find that it has just 1 in it. So we could write 2n plus 1. Okay, we could do that. F of n equals 2 times n plus 1. These are the same thing. See, if I do the math, 2 times n minus 2 times 1 plus 3. 2n minus 2 plus 3. Minus 2 and plus 3. 2n plus 1. This is just an easier way to use the information that we have to write the equation. And you need to know how to do it because you'll be tested on it. Okay, so let's look at another one here. So the sequence here are the numbers 1, 4, 7, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we could probably write the next number in this sequence if we notice the common difference. It's increasing by 3, so we just would keep adding 3, and we could keep adding terms to this sequence. So we know the difference is adding 3. So the recursive would be that the first one has 1 in it. And the next one will always have 3 plus how many was in the one before it. That's just the only thing you have to learn, is that the next one equals whatever the difference is plus how many was in the one before it. Okay, and this is how we write this in math. This again is called the recursive formula. Okay, the explicit formula is where we just write one equation. explicit. So we'll write f of n equals, since we're going to use the first one, we're going to do 3 times n minus 1 plus 1. And again, you're going to see this written the other way. You're going to see this written like this when you get in Alex. F of n equals 1 plus 3 times n minus 1. And they're going to tell you this. They're going to say for n equals 1, 2, 3, dot, 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 dot. That just means you're putting in the first one, the second one, the third one, the fourth one. That's all that means. It's really going to confuse you if you let it, but it doesn't really mean anything, okay, except that you're using the first one. See, if you put in a 1 here, 3 times 1 minus 1 is 0. 3 times 0. That's 0. 1 plus 0 is 1. That's how many are in the first one. Put in a 2 now. 3 times 2 minus 1. 2 minus 1 is 1. 3 times 1, that's 3. Plus 1, that's 4. That just means that there are 4 blocks here. 1 plus 3 times 3 minus 1. 3 times 2, that's 6. 1 plus 6 is 7. 1, 2, 3, 4, 5, 6, 7. Just means that there's 7 of them there. Okay, and really, if it asks you to write out the sequence, right? You know the first one is 1, and then it says plus 3 times n minus 1. That means you're going to add 3 every time. 1 plus 3, plus 3, plus 3, plus 3. Arithmetic sequences. Okay, so now we're going to look at another kind of sequence, and these are the two main focuses in ninth grade, is the geometric sequence. This is the one that multiplies each time. So if we were going to write a recursive sequence, we would note that the first one has how many in it? Well, 1, 2, 3, 4, 5, 6. The first one has 6 in it. And then we notice there are 12 in the next one. There are twice as many. And then the next one, we'll notice there are 24. There's twice as many as the one before it. Can anybody guess how many would be in the fourth one? That's correct. 2 times 24, 48. So our recursive for the geometric, recursive is simply going to be a sub 1 equals 6. And then the next one equals 2 times the one before it. This is all, again, the one before it. The one before it is written a sub n minus 1. That means the one before it. The next one, a sub n. 2 times the one before it. See, here, look at this one. This is the next one after that one, right? 2 times the one before it. It's pretty simple when you understand that. The explicit is going to equal the one, let's take the first one, how many? 6, and then the multiplier to the power of x minus 1. That means we're multiplying it that number of times, times 2. So there's your explicit equation. Look at another. So the sequence would be, the first one is 6, the second one is 12, the next one is, let's see, 8, 8, 8, 24. Notice they're all doubling each time. So the next one would be 48. And we could go on and figure out 2 times 48, 96. So the first one at 1 minute is 6. The next one is 2 times the one before it. So if we were going to look at today's assignment, question 1, decide whether it appears to be arithmetic. If it does, find the common difference. So 2, 4, 8, 16. Um, doesn't look arithmetic, it looks geometric, right? It's doubling, it's not adding each time, so it's not arithmetic. Here, we're subtracting something, the same thing each time, which means it is arithmetic. The common difference would be, what are we adding? We're adding a -4, -4, -4. So, and then this next one is starts at 2, then it goes to 7, then 12, then 17. Looks like it's adding 5 each time, doesn't it? Which would make it arithmetic also. Okay, so now we're going to determine if it appears to be geometric. In other words, the multiplying one. And if it is geometric, we're going to find the common ratio. So something times 3 equal -6? Yeah, it would be -2. And then times -2 again would give you 12. And then times -2. So that would appear to be geometric. And the ratio would be -2. Here, 8, 10, 12. This is adding 2 each time. So that's not geometric. Over here, it appears that we're multiplying times 1/5 each time, times 1/5, which that would be the ratio. Geometric. Number 3. For each sequence, determine whether it's arithmetic, geometric, or neither. So we're determining, are we multiplying each time? Are we adding or subtracting each time? Or are we not doing either of those? Here, I would say we're dividing by 4. Dividing by 4. That makes it geometric. Dividing by 4 is the same as multiplying by 1/4. Okay, so understand that. Here, 18, 23, 28, 33, it appears we're adding 5 each time. That makes that arithmetic. 2, 1, 1, 2, that would be neither adding or multiplying, so neither arithmetic nor geometric. On the next one, they're either arithmetic or they're geometric. We got to determine which it is, and then we got to write the formula, the explicit formula. It doesn't say which kind of formula, it's always the explicit. Recursive will always say recursive. So here, 8, 16, 32 appears to be multiplying times 2 each time. So we have 8 times 2 to the n-1 power. And for some reason, when I pressed 2, it put a C there. Okay. Now here we have 4, 9, 14. it appears to be adding 5 each time. So we started with 4, then we're adding 5 times n minus 1. Now this time I pressed 5 and it put an S. Huh. Here we're going to write a recursive formula for each sequence. As I said, it will tell you when it wants recursive. Now, this one here appears to be multiplying by 5. Okay, so the first term is 2, and then the next term is the one before it, right? Times 5. 5 times the one before it. Over here, the first term is 10, and it appears to be subtracting 4 each time. So, minus 4 and minus 1. Okay, let's try that again in parentheses. Hey, it doesn't like my keyboard anymore today. Okay. Minus 4 plus minus 4 plus the one before it. A and minus 1, one before it. First 3 terms of an arithmetic sequence are given. So we got to figure out the difference. Looks to me like it's going down by 8 each time. So we're going to subtract 8 a couple more times. Okay, 17 minus 8, 9 minus 8. Find the first 4 terms given by this sequence. Well, the first term is the 5, and then it's going to be times 4 each time. That's what that means when you see this written this way. 5 is the beginning, 4 is the multiplier. So we're just going to keep timesing by 4. Timesing by 4. Write an explicit formula for the nth term. 15, 18, 21. Looks like it's adding 3 each time. So explicit, 3 plus. Okay, looks like it's adding 3 each time. So 15 plus 3 times n minus 1. Write a recursive formula. Well, the first term is 2. It's arithmetic. So what are we doing? Looks like we're subtracting 4 each time. Recursive. So the next one equals the one before it. Minus 4. 1 equals the one before it, minus 4. Find the 19th term of the arithmetic sequence whose common difference is 3 and first term is 5. So here we go. Here we go. 3 times, hold on a second, 3, common difference, slope, the first one, n minus 1 plus 5. So it says find the 19th term. So 3 times 19 minus 1 plus 5. And we're going to use a calculator. 3 times 18 equals plus 5 equals 59. Okay. First three terms of a geometric sequence are given. Find the next two. So again, it looks like it's doubling each time. So 2 times 8, 16, times 2, 32, times 2, 64, times 2, 128. Seventh term of the geometric sequence whose common ratio is 1/2. First term is 4. So since we're looking for, let's see, first term times the multiplier raised to the n minus 1 power. In this case, we're looking for the seventh term. So 1/2 raised to the 7 minus 1 power. And we're going to do this in the calculator. 4 times 0.5 raised to the 6th power. 1/16. 1/16. And that is your assignment. Good luck.